Hello, my name is Seth Juarez. I'm Cloud Advocate at Microsoft, and we have here
Greg Buer. I'm a distinguished engineer in Azure ML.
So my job, and this is an interesting job, and you might not know that we have people at Microsoft that do this. My job is to help developers and data scientists be successful with AI in the cloud. So I harass these people all the time because I'm there for you. So today is going to be an example of me harassing the distinguished engineer. Because it turns out that data science, if you've ever done it, is like programming was in 1995. Remember where you had like a code and you would literally email it to someone else? We still do that in data science. We will email Python files to each other. We'll email models. We have these crazy processes. It's all crazy. And machine learning is hard. Do you feel our pain over there at Azure ML?
Actually, I do. I do feel your pain.
This was not rehearsed.
This was You'll notice a theme throughout this talk. So, yeah, we don't even know what to call it. Machine learning, artificial intelligence, data science.
Something.
It's something. It's like a soup. But our job is just to make that easier for you. We're trying to make it more approachable, more understandable, reliable, repeatable. We're basically trying to help you solve your business problems. And over the course of today, what we'll try to do is lay out how we help you do that.
Okay, so I have written here, and he may or may not have seen this, a list of 10 problems that I have. And you are going to solve them. And we're going to hold him to it, right? Everyone's like, yeah, it's 10, Seth. Gosh. The first one is, I'm worried personally that I've already invested in my own files, in my own process, in my own thing, and that Azure ML is just going to go and I have to reinstall and do everything over again. Is that true, Greg?
Well, first, Seth, let me spend the first 45 minutes of this 45-minute talk describing this architectural diagram.
Oh, yeah.
We've got a lot of blue boxes.
Yes.
A lot of arrows.
This is our process, actually, currently.
I even added some red arrows that I drew in myself.
Right.
No, we won't do that. That would be terrible. Yeah, it is hard to integrate into existing processes. And what a lot of solutions you'll see is they'll basically give you an end-to-end solution where you have to take the whole thing, and some of it's good and some of it's not good. Maybe they don't have a hosting story, or maybe their machine learning story isn't very good, but they're good at ETL. And so the way Azure ML solves that problem, or helps you with that problem, is we try to be extremely flexible. We have an end-to-end solution, but each part of that solution is an independent service that they work very well together, but you can basically take the pieces that you need. So, for example, if you're training on-prem, you want to continue to train on-prem, but you're not tracking your training very well, you can use our training tracking service. And basically, this will just keep track of your experiments in the cloud for you. It's not very expensive at all. It's only storing metadata. The storage is basically pass-through cost. And that's an easy way to get on board. Or if you need GPU support, we have GPU support. You can use on-prem for your local computation. For CPU, use us for GPU. Or if you want to do all your training there and host with us, that's very easy. We'll just bring the model into our containers. If you want to train with us and host yourself, you can do that as well. And so that's really something we strive to do. We strive to be as flexible as possible. And so, yeah.
And so you're saying that it's like a buffet, because everyone loves buffets, and I can always get what I want from the buffet. I don't have to do the whole thing.
You don't have to, but you can.
Oh.
We even encourage it.
Oh, thank you. I like a full buffet. I even take buffet purses to my buffets.
Nice.
Everyone knows what that is.
Nice. Homer Simpson.
That's right.
Yeah. And what I want to do is I want to keep this scorecard here. And basically, I want to score what we're helping you with along these 5 dimensions, whether we're helping you bring your data in, or training models, or using those models to score your data, or consuming the results of those scores, or basically securing your workflows. And I could talk a lot about enterprise readiness, because we got all kinds of enterprise readiness stuff. Ashish will talk about that later in the week, so I'm just going to focus on security for this one.
All right.
And I'm going to give myself 4 checks for this one, because you can basically use these services a la carte.
That's nice how we can like make boxes and then check them ourselves. This is awesome.
Yeah.
Awesome. So listen, this is nice and all, but like there's like new frameworks that come out all the time, and the boss is like, hey, TensorFlow 2.0 came out literally yesterday, like 5 hours ago. why aren't all our machine learning models in TensorFlow 2.0? It came out like an hour ago. Can we, do we have, is there like a Azure Machine Learning framework that I have to plug into and do that? Or how can I keep up with what's going on?
Yeah, that's a great point. It's something we've noticed too, and even in our own organizations, we have challenges keeping up because, like you said, things come out all the time. So we have people dedicated in Azure ML to paying attention to this and providing recipes and solutions for you. We basically will take open source as much as possible. We're very open source friendly. Sometimes we make it ourselves. Onyx is something we made ourselves as a DNN runtime. LightGBM we wrote ourselves. We have Responsible AI, Fair Learn. You can go check it out. Sometimes we partner. So MLflow came out for experiment tracking. We partner with Databricks on that in the open source community. And there are a bunch of stuff that we just pull in. We support Jupyter Lab, Jupyter. We support PyTorch, TensorFlow, all kinds of stuff. And as new technology comes out, we'll pull it into Azure ML for you. So for example, like recently, there was this huge improvement in natural language understanding called BERT. It's an unsupervised text model. We very quickly put open source recipes out on GitHub so you could then easily train these things on Azure ML.
And that's cool. We're still waiting for Ernie, right? Now, here's the thing. And this is no joke. I gave a talk in Israel, and they're like the best at AI. And I get up, and they speak their mind. And so I got up, and I'm like, I'm going to talk about TensorFlow. No joke. And the dude goes, hey, like in the middle of a talk, hey. I'm like, don't you work for Microsoft? Why are you teaching us TensorFlow? And I said, we don't care what you run in our cloud. The slower, the better. Because we charge by the... Now it's funny. Okay.
We basically want to be the best place to run everything.
Yeah, and I have a joke, because TensorFlow is awesome, and I love TensorFlow, and I use it, but we don't care what you run in this thing. The newest... I was running TensorFlow 2.0 Alpha 1 in Azure Machine Learning Service before anyone else was. And so it actually works, and it's really cool. But this brings me to the next challenge. We have a lot of different people, from the data to the data scientist to the machine learning engineer, and sometimes things can get expensive. Like, there's lots of, how are you helping with the multiple personas issue?
Yes, this is an interesting question. So basically, this is a problem. You have an organization and you have your talent, and not all your talent is dedicated to data science. So how do you get your machine learning engineers, or just your regular software engineers, or data analysts involved in helping you solve business problems with machine learning? And so what we've been building out over time, and what was announced yesterday, is Studio. And it's been in preview for a couple months. And basically, the new Studio allows multiple authoring experiences in the same UI. And so that goes from a very easy to train AutoML to sort of a modest machine learning person in ML Designer to an expert in notebooks. Now, just because we have drag and drop experience for machine learning doesn't mean that we're not fully embracing code first. This is just a better code first experience. And I want to kind of pop over and show it to you real quick. And you probably saw it yesterday in Eric's keynote. But here's what it looks like. It's just ml.azure.com. And we have these three authoring experiences. We have notebooks. I'm zoomed way in, so hopefully you can see it. And I'll show a bunch of notebooks later. But we have an integrated notebook experience. I'll just click on one. We have an integrated notebook experience. You can also, if you want, launch Jupyter, Jupyter Lab. You basically get to choose your editor. I think over time, our integrated experience will be really, really good. But Jupyter Lab is also pretty good right now, too, and we want to support that. There's also automated machine learning. So basically, this will let you kind of walk through automating your machine learning task. It's pretty cool. You can go pick a data set. Like, what should we do here? Let's try Boston. I think there's a Boston data set. Do car price. Pick this car price data set. You can get a quick preview of the data. So this shows you some example rows. You can see the columns. It's already parsed the column names. You can look at the statistics of the data. So this is pretty cool. For integers, you see the distribution. For string values, you're going to see it's a categorical column, so you'll see the counts of the categories. I could geek out on that for a while. Then Designer. So Designer's our new drag and drop experience. Now, I'm not going to rat hole like crazy on this, but it needs a little explanation. So basically, there are two types of pipelines you can build here. One is this one right here, which is a bunch of pre-built modules. They're really cool. You can have a drag and drop experience around how you do author your machine learning. The easiest way to see, basically, you say, OK, I have a data set. I drag my data set over here. I connect it with a bunch of stuff. I can have a data transformation, like I can add a column or something like this, and you take this thing and drag it there. And you go through and kind of define your machine learning algorithm through these boxes. So it's a no-code experience, but you do have to have a little machine learning experience to know what these things mean. If you want to see sort of one already done, we have a bunch of examples. The screen kind of doesn't scroll super well there, but basically this will build an example for you. I could zoom out. Not that far, but get it? And this is sort of an example experiment. Now, as I was saying, there's actually two kinds. There's also this advanced configuration. And this advanced configuration, if you've been using Azure ML, this is essentially the pipelines you're used to in Azure ML SDK. Right now, we just started this, I call this a palette. So you basically have these two different palettes. And we'll probably come out with more palettes with a consistent canvas experience of drag and drop. But this palette basically only has two things. It has data sets and Python script step. So if you've used Azure ML pipelines, you know that a lot of what you do is a Python script step. Now, conceptually, these two palettes are kind of at a different level. Azure ML pipelines are basically orchestrating complex processes across compute targets for you, whereas the ML Designer pipelines are sort of helping you author a machine learning training experience. Here, you have to write all the code yourself, but it's super powerful. And in the other one, you don't have to write as much code. Like I said, I could geek out on this for a long time. We should probably move forward. But if you have questions on this, feel free to ping me afterwards.
Awesome. So notice that when we were looking at the personas, we showed you from the data engineer, notice that he was able to look at data and play with it, all the way, and some parts that we're going to show later, to the release engineer, to releasing these things. We cover everyone with Azure Machine Learning. It's pretty cool. So now here's the next question.
I get my check mark.
Oh, did you do the check mark?
For training.
You know what I got to do? I got to go in and like make presentations where I like add check marks for stuff. Because it's effective, right? You're like, oh, there's another check mark. But I ask you this. It feels like when it comes to machine learning, if there's someone here that hasn't done machine learning, it feels like it's this huge hill that I'm never going to be able to climb. Can you help me with that?
It is hard to get started. This is one of the things, because there are so many packages and stuff like that, how to set up your machine becomes quite a challenge. So what we have for you to set this up to get your data scientists moving quickly is we have this Azure Machine Learning Managed Compute Instances. We have this for compute clusters as well. But this compute instance is kind of special. It's super easy to check out. You can start and stop it, so you can control cost. You can pick any SKU you want, so you can get an inexpensive one, you can get a GPU one, you can get a lot of different types. And we automatically set it up behind a proxy, so it's very secure. And we open ports, so it's easy to run Jupyter Server on it. It's easy to run RStudio on it. It's easy to run TensorBoard on it. It basically just works out of the box. And then as you're defining your computation, whatever it is that your training experiment, when you're adding these little pips, you're keeping track of these. And then the only thing you need to move to production is these pip packages or the conda packages that you've installed. And all the while, you have sort of the full power of all the data science open source repositories on this machine. And just to show you real quick how easy it is to check out, I want to pop back over here. Scroll down to compute. Here are mine. You can also check out these training clusters very easily. By the way, this can all be put behind role-based access control. So the IT, you can basically control spend and what the data scientist is allowed to do. I wouldn't show my boss this one. I made this one yesterday. It's probably costing me money. But yeah, so if I want a new one, I just say, this guy, I check new. I pick my SKU and name, and it's just kind of off and running. I'll pick the standard SKU. It takes maybe 1 or 2 minutes to provision. You can have multiple. You can have them started. You can start and stop them. You can set them up for different, like if you want, GPU set up on one and CPU set up on the other. It's just really easy to do. So yeah, that's that one.
And that's an interesting thing because, look, I once had a model that MSR sent to me. They're like, Seth, put this into production. And they were using like Python 2.7 and PyTorch version 0.2 point whatever. And it was really hard to actually get that kind of stuff to work on my machine because environments are hard to set up. Notice, for getting started, you can literally just start up a machine that has everything that you need on it, and you can run it right away, which is pretty amazing when it comes to actually playing around with these models and doing the actual compute. But, next question. We talked about compute, but what about my data? Because obviously everyone knows that machine learning is the compilation of data into meaningful algorithms. That's what I say, or at least that's what the internet says. I asked them
the
other day.
Yeah.
But my data, how do you access my data? How does this even work?
It's a good question. First, I need to give myself a check mark.
Oh, yeah. You've been giving yourself check boxes all day. This is therapeutic. I love it.
Here we go.
Okay, nice.
Okay, next question. Yeah, that's right. It is difficult to access your data. Your data ends up being everywhere. It's in SQL. It's on Blob. Oh, I'm in ADLS Gen 1, and now we have ADLS Gen 2. Or I'm in file share. I could be local. I'm on my on-prem. It's really quite difficult. So what we've done here is we built data sets. And data sets, it sounds like a simple thing. They're incredibly powerful. They basically allow you to have consistent access across a wide variety of storages so that your training code can be written consistently. So you can say, this is the data set. I want to train on this data set, pass the data set, the handle to the data set. They're tracked and versioned. They're fully integrated into the SDK. They're fully integrated into Studio. They're really quite powerful. I want to show a couple things about them. Just to show how easy they are. So we have this concept of a data store and a data set. A data store is essentially the credentials that you need to access whatever storage it is. So basically, we get your credentials, we put them in Key Vault. Then whenever we need to access the data on your behalf, on the remote compute target, we access your credentials long enough to collect the data, to grab the data. By the way, our data sets are always references. So we have a reference to a location. Even if that's a SQL query, it's a reference to a view in SQL. So we don't copy the data. We offer functionality like snapshot if you want to copy the data, but by default we don't. So here's, I get the default data store. Every workspace comes with a data store. Like I said, the storage is super cheap, and if you don't put anything there, it doesn't really cost you anything anyway. You can upload files from your local machine. It sounds kind of rinky-dink, but like I was in a meeting, I was probably supposed to be listening, but I was actually playing with it, and I had maybe 30 gigabytes of data. It was around 1,500 files, and I uploaded it well within the time of the data, like time of the meeting. Like it was maybe 20 minutes, and then all the data was uploaded. Now, we probably have a good connection, but I was even on my laptop Wi-Fi. So adding new data like through this thing, let's see, I go down to data sets. What's the picture for data sets? That one. So you can add data sets even through the UI this way, create a data set. We have different types of data sets. So like we have, maybe I'm going to pull these from local data. We have two types. We have file data set and tabular data set. We actually have a new one coming out called time series data set. I'll skip that one for now. So file data set is basically a collection of files. So if you're training an image classifier, you can just say point out to all these files, and it'll collect them all for you in a hierarchy. And then when you need the file at runtime, it gives you a handle to that file in a mounted share. So it looks like it's local, but it's not. And a tabular data set will actually parse the data for you. So we'll be able to give you rows of the data instead of just giving you a handle to the file. That doesn't have to be just one file. It could be like 10 files or 20 files. It's just that you're telling us that you want us to parse that data for you and understand the schema of that data. In both cases, I use both of them all the time. Very, very powerful. Let's go back to our notebook. see what else I want to show you. And then basically, you can either register the data set or not register the data set. I recommend always registering the data set. We take an approach with data sets that the files eventually are moved to the cloud for you to process them. And the reason is, when you start to launch stuff on remote compute, they have to be there anyway. We started with like in summertime, we had a version of the API in preview where you could have local data as a data set and remote data as a data set. But it kind of just confused users. Like, they'll run a job on their local data set, and then they'll launch it on the GPU in the remote cloud, and then the remote cloud tries to access it on the C drive, and of course, it's not there because it's only local. So now our data sets are basically cloud-based data sets. And you can, when you register them, then you can reference that data set later by string, just by the string name. So you can see here, I've registered the data set. Now all I have to say is data sets of Titanic. We can also profile the data. You saw a brief profile earlier. So yeah, they're pretty powerful. Later in the talk, if he asks me the right question, I'll show you an example where we're using the data set in a computation.
Now, here's the thing, and I want to emphasize this. Again, if machine learning is compiling data into algorithms, if everyone has the data on their own machines and the data is changing differently on people's machine, how could you ever reproduce a model consistently across all of your data scientists? You just can't. And so this is why we've decided to go this way. Imagine being able, all of your data scientists, to work on exactly the same data and to experiment however they wish by literally mounting a data set into their experiment, which is pretty cool. So I think, did you give yourself a check mark?
I did while you were talking.
Okay, I think you've earned it.
Yeah.
Now here's the thing, because we talked a little bit about how data changes across hard drives, but what if data is changing across all of our things and I need to retrain old models? I mean, do I have to do everything all over again? Is there something you can help me with there?
Yeah, that's a good question. Oh, I forgot. This is my geek data side. I just put this up here for fun, but it actually just shows the flexibility. And I even put the APIs in there. So like, even if you're grabbing Parquet files, you use the same APIs. It's really cool. And you can mount it. You can download it. Daniel will talk about this more later in the day, so sorry, I just threw that one.
I think you gave yourself a checkbox prematurely,
It's
Greg.
possible.
I feel
it's
like
possible.
you cheated.
But that's a wacky slide, so it's really not part of the presentation. It's snuck in there.
Nice.
Yeah, it is difficult to retrain. And our solution here is really pretty straightforward. What we talked about, machine learning pipelines. Machine learning pipelines are really, really powerful. They actually come out of MSR and Microsoft Bing from about 12 years ago when we started them. And they're how internally we've done machine learning for a very long time. They're very robust. You can have complex orchestration across compute targets, as I was mentioning before, for your computation. And they offer a bunch of other things. Like, if I train with a one-step pipeline versus training with a script step or just a script, it's easy for me to automate that. I can just right-click on that thing or say, publish that endpoint, and now I have a REST endpoint that I can call from anywhere. So it's easy. So here's something that comes up a lot. It's like, there are so many different kinds of pipelines. There's ADF pipelines, and there's Azure DevOps pipelines, and there's AML pipelines, and even AML has multiple types of pipelines. And it turns out pipelines are just popular because it's an easy way to orchestrate your computation. AML pipelines are really good for orchestrating the part of your computation that has to do with machine learning. So if you have a complex process that includes machine learning in it, then we provide a REST endpoint so that an ADF job or something can call into us to execute our part of the pipeline. Because you really want to keep the data scientist authoring in the data scientist native experience, which is what we offer here. And then the other thing is you can schedule it. Like, I even do a bunch of stuff at work where I want this process to run every day. It's not necessarily a production process, but it's important to me to run every day. And I always put that behind a pipeline. So I just want to show you real quick the difference between writing a one-step training job and a one-step pipeline training job. They're almost exactly the same, which is why I encourage you just to use pipelines. This is all boilerplate code, if you can read that. You have to get an AML compute target to run on. You have to get an environment to define in what environment your program is going to run. The Python script step is just these inputs. You know, you've got name. That's just for fun, so you can see it in the output. You've got your script entry point. You've got your folder that you're going to run from, where you want it to run, and in what environment. Allow reuse is really cool. If you have a complex pipeline that runs multiple steps, and we can detect that the input to that step is exactly the same as the previous time you've run it. We just take the output from the last time you ran it. And most of the time that's useful. Occasionally it's not, like you know that the data underneath a URL or something actually changes without, which is opaque to the system. Then you say allow reuse is false, and you can force it to run. So it's basically up to you, but it makes a lot of our jobs in Microsoft, actually like 40% of the nodes in the job don't have to run because they reuse. And then if you look a little bit farther down, you'll see almost exactly the same thing. Sadly, we didn't name the names exactly the same thing. That's something we're trying to get better at. But you see like script name, source directory. This one's called entry script. But it's almost exactly the same. So the normal way to do it would be this PyTorch estimator. But what I'm suggesting is to use either Python script step, or even there's an estimator step as well that mimics it even more closely. And then here, this is kind of a secret, just because I'm geeking out on this one.
Nice.
This is kind of a secret. Actually, you do a bunch of stuff here. Like you give this, this entry point, and you capture your code in this step. But then the next time you want to run it, you actually do that same stuff again. Either you copy and paste it or what. Actually, under the covers, we have something called a module. And what a module is it captures all this information into a reusable component. So we haven't exposed that functionality for reasons, but soon we will. And when we do, what you'll be able to do is you'll be able to turn Python script step into LightGBM step, and you'll be able to have your own custom steps. And inside your code, you'll be able to parameterize that however you want. And actually, that's internally what we do at Microsoft, is we have thousands of these actual modules that are reusable components that are used throughout the company. So look for that in the coming months, weeks. But it's really powerful. So I just want to, I've said that like 5 times, but I'm secretly in love with pipelines, which is why.
All right, you can give yourself a check mark.
And a heart smiley face.
Nice. So we are going to go into lightning round mode because we have about 10 to 30 years left of these people. So here's the thing that's important. For some reason, people train these things and they put them out in the wild and they just let them run. How do you know your model isn't racist? I'm trying to be honest here.
Yeah.
How do you know your model isn't acting ethically? Can you help me with that? This just got dark in here. Wow.
Yeah. Yeah, it's a good point. You want to be able to introspect your data. You want to be able to understand the models that you build. Not just how those models are globally, but when they score something, how do I understand what it is that they're scoring, and did they score it sort of fairly? We have a bunch of stuff around this. Inside the product, we have interpretability. So you'll see the option to have explanations and interpretations. We kind of use these interchangeably, but they're basically 2 things. It's either understanding the global properties of my model that I trained with respect to, say, input columns or features. And it's also, given an example, why did it score this way or that way? We also have an external project that Sarah Bird will talk about later in the week called FairLearn. It's really cool. I don't have time to demo it today, but I do have the GitHub URL. And basically what this says is, okay, you have financial data, you trained a financial model. For example, are you giving the same opportunity to people in one area of the country versus people in the other? Or are you giving, based on gender or whatever else that might be biased in the data or in your model? It's really cool stuff. A lot of it comes out of MSR. I just encourage you to take a look here. I also will show this explanation. Let's pick a run. This happens to be a run that I ran that has an explanation in it, I believe. Let's get it to load. So here's an example. Like, here's the global importance. This happens to be the Boston data set, which is housing data. But if you just look across, you'll see, okay, these features have the most influence on scoring in a global way. They have the most influence on the model moving from here to here. And if we look at the summary of importance, you can look at it this way. You can change this to be a violin. I didn't really know there was such a thing, but it's pretty cool looking. Your boss will be impressed. And there are actually 2 more tabs on here that we took out because we're working on redoing them, but you'll see 2 more coming shortly. And then, like I said, the fairness stuff will come into. And I already showed you data profiles.
And this is cool because we will run the things on your model, and there is ways to actually look at the features and how they influence your prediction. And so if there's certain things that are unethical, you'll know right away before these things even come out, because we're super keen on ethical AI at Microsoft. So we're going to go super lightning round. I'll let you spend a lot of time on the next one, but the next two you're going to have to answer in one sentence. Right. The question now is important. Yeah. How do I get cloud scale machine learning solved?
This was originally the thing I wanted to geek out on the most. This is really quite new. So we had this problem where, it's amazing, but there are many companies that come to us and say, I want to train 5,000, 10,000, 40,000 models every day, which is just not I mean, we didn't see that coming. Most of the time in Bing, we train one big model, or Office, we train one big model. So training 40,000 models a day is pretty unusual. But if you look at banks with ATM machines predicting how much money they need and when to refill them, or a lot of oil companies will say, hey, I'm trying to predict all my oil wells. I have 8,000. I want to predict them daily. If you look at the retail market, they want to predict per store. A lot of them want to predict per SKU. Some of them want to predict per store, per SKU. So a lot of opportunities to do many models is what we call it. And so our original solution to this was, was basically an MPI step in a pipeline where you used MPI to parallelize the workload. It was okay. You had to split the data yourself. It didn't have very good fault tolerance. If you use MPI, you know that if one node dies, they all die. It didn't have retries and stuff like that. So we built a new one. The new one's called Parallel Step. It just came out yesterday. You can put it in a pipeline. It's really cool. It's a managed stack. So we set up the master nodes for you. We partition your work for you. You just tell us how many nodes in your cluster you want to run on and how many workers per node, and we launch those. If your process dies, we'll spawn it again. If your process dies while you're executing a task, we start the task over. We keep track of everything. If the task dies on a certain process, we restart the process, but start the task on a different machine. And we'll do that 3 times. And then after 3 times it still doesn't work, we put it in a poison state and then give you a report afterwards. So let me switch real quick. I know this is my last fun one. So here's an example. I trained this one a little while ago. Actually, I'm going to start another one, if Seth lets me. It's really not very much code at all. I even have this SSH in here to see what happens. Oh, man. Maybe I have to refresh.
While he's getting this done, if you ever try to solve a computer science problem with distributed computing, then you always have 2 problems. These are the jokes, people. These are the jokes. So it turns out that distributed computing is actually really hard, especially when you're trying to do something as complex as machine learning. And so the ability to add a parallel step, and we manage the distribution of these things across a bunch of nodes that you set up, is amazing. Now, here's the thing that's also amazing. We make it so that you can set on your clusters your node count, mid-node count to 0, max node to whatever number you have. And if these things are sitting there doing nothing for 5 minutes, they will shut down. And you can change that 5 minutes to whatever you want. And so you may have a huge workload of models you need to build over the weekend. It will scale up, and it will scale back down on Monday, which is great. And so you save on the cost, and you're only using the compute that you actually need.
Yeah. OK, so I might have mucked that one up. But let me show you how I ran it a little bit ago. So basically, it produces a log for each output. It has a report. It'll show process tasks. You can see this processed 971 models. If I go to the outputs for this guy, might take a second to load. But you can see it trained 971 models. Each model was about, I want to say, maybe 30 megabytes. So they're not huge, but but it basically fans out all these processes, trains all these models, and does it in a single step. Let me see if I can show you the graph real quick.
And as he's clicking through this, notice that we're all kind of taking for granted that all of this stuff is in one place, not on some random person's machine, right? This is somewhere where everyone can see it, which, and I kind of, like as he's doing that, we're all taking it for granted, but this is not the way data science is done today, but this is the way that it should be done.
Yeah, and you can, this is the cluster I trained it on, CPU cluster 4. It's idle now because the job's over. But yeah, I mean, that thing's really cool. I encourage you to try it out. If you have a workload, it'll do parallel batch scoring. It'll do parallel training. The function is really quite simple. You, see, I'll show you how to write the code real quick. I'll show you that afterwards. But basically, it's only two functions. There's an init function that runs when the node first starts, and there's a run function. And you get to specify, like for a file data set, you basically pass in just a file reference. You can pass in 5, you can pass in 1, and you just process them in a loop.
All right, so I think we're almost out of time, so I'm going to quick ask you the last 2 questions. How much time do we have? Oh, we have 9 minutes? Is that the right time? Oh, good. I can go a little bit slower. I was looking at the clock. I'm like, holy cow, are we done? No. So I'm going to ask a little slower then.
Okay.
Here's the thing that's actually really hard, because someone spends a whole bunch of time making this beautiful model. Models are like puppies. They're cute, right? They seem like they're free, but you got to take care of them. They pee all over the place. And you know, you take care of them forever. But then when you release them, it's really hard to put them into production because of environment issues.
Yeah. Yeah, that's true. That training check, I had to go back to other ways.
Oh yeah, you give yourself a check.
There's no way I was gonna, I'm a dev, so there's no way I was gonna PM that thing and make the boxes bigger.
Right.
I just put on the other side.
Nice.
Yeah. This is the nerd graph for parallel processing. You can check it out later. Yes, it is difficult to replicate the training environment. So what we've done there,
well, I think people want to take a picture of that parallel step.
Yeah.
Everyone was like, ooh, like they didn't want to take a picture of us. They liked this slide, man.
Pankaj made this thing. I feel bad for him taking.
Yeah, no, let's put it up and let's take pictures of it. It's beautiful. No, let's look at it.
You can tell it's done by.
Well, it's awkward.
Marketing didn't help us with this.
Nice.
One. Yeah. Yeah, no, it is. It's difficult to replicate. You have a training environment, and you set it all up, and it's local conda. And even though you set it up properly in your training code, when you go to run that in production, you have to replicate that environment. So what we've done to solve this problem is we have these managed environments. You define the environment. You can store it as a first-class citizen. You can download the environment. We're adding support for integration with Docker, so you can translate between Docker files if you want to take it with you. But basically, it stores, we used to have a mix of a run config. It stored the environment along with, kind of mixed with what code I was going to run. So here we've pulled it out, made it a first-class citizen, allow you to save them in your workspace. They're very easy to use, and now you can reuse them. So after you define it one time, and you write training code, or even you want to put it in a hosting environment like an AKS cluster, you just say environment equals Greg1 or something, and it'll go find out what that environment is and deploy it in your cloud. Sounds simple, but it actually ends up being really useful.
And this is really cool because before, right, because when you're putting this thing into production, it's not just the model, because the model is like just a file, like, like an HDF5 or a protobuf file. But that in and of itself is useless. You have to have some code that wraps it and actually executes the model in a usable way. And so what happens is, and this is so new that I actually have to rewrite all my demos, thanks for that, Greg, to something that I like that's even better, where now we can encapsulate all of that into a single thing that then can be executed, which is really cool. Which brings me to my number 10 question.
Yes.
How are you helping me out with security?
Yeah.
Because, usually what we do is we corral all the data scientists into this air-gapped thing, and they can do whatever they want. But sometimes I don't want to have to worry about, like, did I have the right port open? Are you helping us with that?
Yeah. Yeah, no, it's a good point. It's something Microsoft strives to be great at. Basically, right now we're adding support for RBAC control. So basically, you can define custom roles very easily to say, this is what a data scientist can do in the workspace. This is what a data scientist can't do. This is what an ML engineer can do. You've seen us adding support for VNet for all the things that you want in VNet, whether that's your ACR or your storage or your compute. Some people even want the whole workspace in the VNet. We've added support for that. Of course, we've always been encryption, SSL. All your data at rest is encrypted. All of our services talk through SSL to each other. We support SaaS tokens. This is something that it's just AAD. This is just something we do at Microsoft, is security comes first. Later in the day, like I said, Ashish will talk about all kinds of enterprise readiness things, so I didn't want to kind of take his thunder on this one. But I just encourage you to go to that talk. Daniel's also talking later in the day. We have some MLOps tomorrow. A bunch of good talks on that.
Fantastic. So hopefully you've seen, we've gone through 10 different things that are of concern of all data scientists that are running things, or if you're an enterprise and you have a data scientist, like just think of this one silly example. Let's just say Bill was your data scientist, and he decides to leave, and Sally is a crack data scientist, and she comes in. Usually what happens is the data scientist from before leaves, and so does all of that institutional knowledge, right? Let's just say they started, because if I'm doing something and like, hey, do a thing, I always start with the simplest of things. Logistic regression, decision trees, dumb things. And then when the dumb things because they usually work, when the dumb things don't work, then you move on. But if I've done all that work for a year and then Sally comes on, what is she going to do? Well, she's going to start again, same problem, decision tree. That whole process is lost. Now with Azure Machine Learning, you have a single space where all of this stuff can be saved. You can see the things actually running. You can see the outputs of the things running. You can see the actual environments of where the things are running. It's all amazing, and you can see the actual output of the execution with the log files. And we feel like this is the next step in doing data science correctly in the enterprise and for anybody. We're really excited about this. If you go to ml.azure.com, you can go there. Oh, there's a bonus?
There's a bonus slide.
Oh, man.
I'm going to explain to you what MLOps is.
Oh, my goodness.
We have this
Bonus.
conversation all the time internally. So some people think it's about model deployment. Some people think it's about automation. Some people think it's about integrating well with DevOps. Some people think it's about understanding whether the data into your models in production are drifting so that you can do retraining. Some people think it's really good command line support because you really want to automate stuff. Some people think of it as CI/CD, but for machine learning, like you said, 90s to now. Some people think it's really about understanding this model. What's the lineage of this model? Where did it come from? Some people think you really need a full audit trail. Some people think it's about reproducibility. It's a specification. I hear that sometimes. David will tell you it's a way of life. I think really it depends on where you're at in your org's journey. Like, if you're new to machine learning and you're just infusing AI into your products right now, it could be the whole thing, because we have a prescriptive approach for how these things should be done. At the same time, if you are an expert, if you're Facebook or something, and you've been training extensively your own models for many years, and you have hundreds of people who do machine learning, it might be us just helping you with best practice on refreshing models in production using data drift and retraining. So I think it really depends where you're at in your journey, and I think that's what kind of causes some of the confusion around this sort of automated machine learning, reproducibility, retraining type stuff. It's really where you're at on the journey.
And this is awesome. So not only do we have the space that I was talking about, we also have another space where you can actually take all of these things and put in production. If you're using Azure DevOps, we have stuff in there. It's pretty cool. We're very grateful for you all coming. There's a bunch of other sessions that you can go to learn more. We've actually done like a whirlwind kind of thing. And obviously, please evaluate this session if you can. I think we have a slide for that, don't we?
Oh, sure.
Thank you. Thank you so much for coming. You all are the best.